Hello YouTube, we're back. What are we doing today? Rational functions. Excuse me, rational functions, part 2. Alrighty, ignore the bell. So the homework tonight is page 228, multiples of 10. Here's an example of what we'll be doing there, okay? Let's say page 228, number 27, says to graph f of x equals x squared plus x minus 12 over x squared minus x minus 6. And it says step 1, use long division to figure out what the graph looks like. What? Let's try that. Step 1, do long division. Rewrite this sort of as in partial fractions form, sort of. Okay, so what does that mean? Take the denominator. That's it squared. Divide it into the numerator. Not depressed, we're okay. Okay, and so what's x squared divided by x squared? It's 1. So 1 times x squared is x squared. 1 times negative x is negative x. 1 times negative 6 is negative 6. Let's add the opposite, and we get 2x minus 6. What does that mean? That means that the dividend, x squared plus x minus 12, divided by the divisor, x squared minus 8 minus x minus 6, is equal to the quotient 1 plus the remainder, 2x minus 6, over the divisor, x squared minus x minus 6. So, in other words, this is the remainder because the degree is less than what we have in the divisor, so that's when we know when to stop. But what does that tell me? Well, look at this. Look at this rational function. Is this top heavy, bottom heavy, or equal degree? That's bottom heavy. Remember, as x gets huge, bottom heavy goes to 0. So for large values of x, this graph looks like y equals 1. Guess what? This is a horizontal asymptote. We cannot pass the line y equals 1 when x gets large. There you go. Also, x squared minus x minus 6 is 0 when? That would still give you when the function is undefined. Now remember we talked about this yesterday. The function is undefined when the denominator is 0, but that may be a vertical asymptote or a hole. Let's talk about that. All right, so step 2 on this question says to see what you can tell me about what the graph looks like by factoring. All right, so here's step 2. So don't forget, f of x is still x squared plus x minus 12 over x squared minus x minus 6. Okay, so step 2, factor completely. Okay, there you go. So f of x is, so let's see, how do you factor x squared plus x minus 12? Let's see, what multiplies to negative 12 and adds 2, positive 1? How about x plus 4 and x minus 3? Okay. And how does the denominator factor? What multiplies to negative 6 and adds to negative 1? How about x plus 2 times x minus 3? Notice these cancel. So if you set the denominator equal to 0, x equals negative 2 is bad. That's a vertical asymptote. But x plus 2 equals 0 makes x equal to 2 bad. That's bad. That's a vertical asymptote. But if we make x minus 7 equals 0, x equals 3 is bad. That's not a vertical asymptote because this factor canceled. That's a hole. So let's write vertical asymptote. At x equals negative 2. X equals negative 2 is a vertical line. But we have a hole at x equals 3. Can you fill the hole? What's the y value that would be missing? Well, look, in other words, the function is x plus 4 over x plus 2, except where x is 3. These are not the same. If you graph them on your calculator, it will not be the same graph. The difference being that there's a hole at x equals 3. But look, what if we plug in 3 into x plus 4 over x plus 2? Don't you get 7/5? So that's the y value that's missing. Okay? Alrighty, there you go. So now we've got some asymptotes, and we have a point, which is really a hole. All right, step 3. Well, what about the x and y intercepts like we usually do? Again, f of x is x squared plus x minus 12, just reminding you what we're doing. and x squared minus x minus 6 is the denominator. And so step 3 is, can you figure out the x-intercepts? And if there's more than one, and the y-intercepts? By the way, there can only be one y-intercept, because if you hit the y-axis more than once, you're not passing the vertical line test. And these are rational functions. They're functions, right? All right, so the x-intercept is when y is 0. If f of x is 0, you set the whole fraction equals 0. But in other words, when is the fraction 0? When the numerator is 0. Okay. And so let's solve. Well, we already factored this, right? Didn't we? Wasn't it x plus 4 and x minus 3? So x plus 4 is 0, or x minus 3 is 0. So x is negative 4 or 3. But that's not the answer. That's the work. The answer is name the point that it hits the x-axis. Well, when y is 0, x is negative 4. Or when y is 0, x is 3. There you go. How about the y-intercept? Well, y-intercepts are easy. Just plug in 0 for x. What's f of 0? 0 squared plus 0 minus 12 over 0 squared minus 0 minus 6 is negative 12 over negative 6 is 2. That's the work. What's the answer? When x is 0, y is 2. That's a y-intercept. So look, now we got 3 different points to help us graph the curve. Nice. I like that. More information, the better. All right, step 4. Let's talk about the domain and the range. All right, so again, f of x is x squared plus x minus 12, just reminding you what we're doing, over x squared minus x minus 6. Now we want to talk about the domain. So this is step 4. What's the domain? And what's the range? Okay. Now remember, the domain is when this thing is defined. So in other words, all the x values that solve this inequality for not equal to 0. We're going to find all the x values where we don't get 0, right? Okay, so what is that? Well, don't forget, we factored this already. So it's x plus 2 is not 0, and at the same time, this is an intersection, x minus 3 is not 0. So x is not negative 2, but we knew that. We have a vertical asymptote there. And x is not 3, but we knew that. We had a hole there. And so there's your domain. X is not negative 2, and x is not negative 3. So if you intersect all real numbers not equal to negative 2 with all real numbers not equal to positive 3, you get all real numbers except for negative 2 and 3. There you go. That's the domain. Now the range we know already, because remember here, we have a hole at y equals 7/5, so that y value isn't being used. And we have a horizontal asymptote of y equals 1. The curve gets closer and closer and closer to y equals 1, but the function value is never 1. So let's say that y is not 1 and y is not 7/5. There you go. There's your range. And now, okay, let's put all this stuff together and see if we can graph it. Now, based on step 5, the graph, I do step 6, the limits. So I'm going to try and fit this all on one page, okay? Step 5. Do the graph. Graph everything that you just figured out, right? And then step 6, describe your graph in terms of limits. What does that mean? We'll talk about that in 1 second. All right, so here's your y-axis. Here's your x-axis. Here's your x-intercept right there. But wait a minute. At 3, I thought 3 comma 0 was an x-intercept. Where do we do the x-intercepts? 3 comma 0. But didn't we figure out there's a hole at 3, 7, 5? Be careful. This doesn't happen. D and E. That intercept does not exist. Okay, so let's draw that hole. At 3 for x, and 7/5 is like 1.4 for y. There's a hole. Okay. Also, we have a horizontal asymptote y equal to 1. I don't like that. Let's say that. Okay. And we have a vertical asymptote x equals negative 2. All right, so what does the curve look like? Oh, and we have a y-intercept of 0, 2. Here's the origin, here's 0, 2. There you go. That's all the information we have. All right, so the curve has to go above the y equals 1 or below the y equals 1. It can't be both because that wouldn't be a function. And for large values of x, are getting closer and closer to 1, but we're not crossing y equals 1. But as we get closer and closer to x equals negative 2, where's it going? Is it going up so it doesn't hit the vertical asymptote, or does it go down? Well, look, it exists at 0, 2, and it's got to go near this hole. So it looks like this, sort of. As x goes to infinity, y goes to 2. Oh, sorry, y goes to 1. As x goes to negative 2, y goes to infinity. There you go. And where does it exist for, where's the curve for x is less than negative 2? Well, it doesn't occur above y equals 1, right? Because we have an x-intercept. So it's got to go down there somewhere. So if it can't hit y equals 1 for large negative x values, and it can't cross x equals negative 2, got to look something like this. And there it is. There's your complete graph. I might as well label it. Y is equal to x squared plus x minus 12 over x squared minus x minus 6. Okay. And what about the limits? All right, let's talk. What's the limit of your y values, f of x, when x goes to positive infinity? Well, as x goes to positive infinity, y is going to 1. Okay. What's the limit as x goes to negative infinity, the limit of your y values? Likewise, as x goes to negative infinity, follow the curve, it's getting closer and closer to y equals to 1. Okay. What's the limit of your y values as x approaches negative 2 from the left side? Well, if you follow the curve, as x goes to negative 2 from the left, y is going down to negative infinity. You're just describing the graph, really, right? Okay. Notice this negative 2 with a negative on top. That second negative is not a negative. It's from the left. It means from the left. So we're approaching negative infinity. What's the limit as of your y values as x approaches negative 2 from the right? Notice that's not a plus sign. That just means from the right. So follow the curve as x gets from the right side. As x gets closer and closer to negative 2, y is going up to positive infinity. There you go. And then there's this other interesting limit. Let's see, where can I put it? Well, I'll put it down here. What's the limit of f of x, the y values, as x approaches 3 from the left? Well, follow the curve. As you go toward 3 from the left, x equals 3 from the left side, y is getting closer and closer and closer to that y value, that had the whole of the y value, which was 7/5. And likewise, if you do the limit of your y values as x approaches 3 from the right, well, let's do it. From the right, it starts near 1 and it goes up a little bit, up to 7/5 again. Yep, there you go. So these are all the limits that are important here. All right, so limits at infinity, limits at negative 2, and limits at the whole, limits at 3. All right, and that's about it. So that's your 6 pages on your test this week, coming up real soon. Hope you practice that up, doing your homework. Page 228, multiples of 10. And I think we are done. That's a good example. We're done for now. Thank you. Bye-bye, YouTube. Whoopsie, where did it go? Bye-bye, YouTube.